All right, these are problems 1 through 5 on review day number 10. First one says we have a function and we're told f of 1 equals negative 2 and f of 5 is 7. So when the function is 1, we're down here at negative 2. When we're at 5, we're up here at 7. And we're saying which of the following would guarantee that the function has to equal 0 at some point between 1 and 5. Now, they're basically saying is what would guarantee that we have to cross this axis here? Would the integral from 1 to 5 have to exist? That's an odd one. You might feel like, yeah, maybe it does, but I could draw this in a way where, say, it goes like this and then jumps up to here, and the integral from 1 to 5 does exist, that area does exist, but it doesn't necessarily equal anything there, so we throw that one out. Does f have to be increasing the entire time on there? Obviously it increases in general, but we could be going up and then coming back down or something like that. So it doesn't have to be increasing the whole time. Does it have to be defined for all values in the closed interval? Well, we could, again, define it. Even the one that we did here at the beginning where it's open here but closed there, that's defined for everything but doesn't necessarily equal it. The only thing that guarantees it is simple enough. It has to be continuous. When I put my pen on the paper here, I don't leave it off the paper until I get to there. At some point, I'd have to cross over. So C is our answer for that one. Our next one says the acceleration of a particle moving along is given by this. At what time is the velocity decreasing the most rapidly? Well, how we would know if a velocity is decreasing is by looking at the acceleration. So really what this is saying is when is a of t at its minimum from 0 to 8. So what you should do is put y1 equal this function here and graph it from 0 to 8 and see when it hits its minimum. And if you do that correctly, you should have had at 1.420. Okay, so that's all we're doing there is graphing that and seeing when does it hit its minimum, and that's at 1.420. The next one says the average value of a function from 2 to 4 is 3. So if we do that average value idea, it's 1 over 4 minus 2 times the integral from 2 to 4 of f of x, and we're told that that average value is 3. Okay. Now they say what's the area of the region enclosed by the graph f of x between 2 and 4? Well, that's this thing right here. That's the area. So if we just multiply by 2, that area is 6. So if you know how to set up the average value and you know what that piece of it represents, then that's a pretty easy problem. Next one's real kind of strange. They give you this weird long table and they say what's the limit to the best of our approximation as x approaches 0 of this? Well, as you look, as x approaches 0 from the left and the right, as it gets closer and closer to 0, it sure does look like f of x is approaching a value of 0 itself. So if we had to make a best guess, our best guess would be that we'd put 0 in here and we would end up with e to the 0, which is 1. So we had to take our best guess. That's really all we could say. And then for this last one here from 1 through 5, we've given a slope field and we're asked to figure out which would be a possible equation that would go through the point 0, 1. So 0, 1 is right here. You could kind of trace it if you want and see that it kind of comes up and then comes back down and is leveling off. So we have kind of like a hill, if you will. All right. Does cosine look like that? At one part, cosine looks like that, but not forever, right? Cosine goes up and down, so no. Does 1 minus x squared? That's a parabola that opens downward. So again, for a little bit this does, but not for the rest that's tailing off. E to the x is an exponential function. It looks kind of like this. So again, cosine looks like that. 1 minus x squared looks like that. E to the x would be exponential, so that's not working. A square root is just a quadratic that's been turned over, so it kind of looked like that. Now this one we're not as familiar with, but it's the only one that's left over. And if you were to play around with some numbers for x and things that are out there, you'd come to find that that is actually the answer here. That's the one that could maybe make that shape there.